Here we go again with some stoichiometry. It's one of those lessons that's very crucial to chemistry. You'll see it again and again throughout many different types of lessons in chemistry, so you really want to get the foundation. You really want to understand how to work and calculate your stoichiometry. So we'll just work out a few basic problems just to get the understanding. We'll do some mole to mole conversions. We'll do some mole to gram to gram, and mole to atoms. So the best way to get better at stoichiometry is just practicing problems and redoing it because it's the same process over and over and over again. This video, I recommend pausing it, trying the problem by yourself, and then checking your work after the fact to see how you did. So with that said, let's just jump straight into it. Let's do some problems. So our first problem says how many moles of iron 3 oxide are produced when 0.3 moles of iron is reacted. Alright, so let's pick out our information to see what we got. It says how many moles of iron 3 oxide. So this is my iron 3 oxide if you don't remember your nomenclature. Now I'm looking for moles. Are produced when 0.3 moles of iron is reacted. So this one is 0.3 moles. Now it didn't say anything about oxygen in this problem, so we're going to assume it's in excess. We're not going to worry about it. Our equation is balanced. Always make sure your equation is balanced before you begin, because if it's not, it may throw off your work. So our equation is balanced, so we can continue. We do not have to do a mole conversion since we're already in moles, so that's one step done. So let's set up our dimensional analysis so we can convert from iron moles to iron oxide moles. So I got 0.3 moles of iron. I stick that over 1. I set up my ratio. The balanced equation is your stoichiometry. That is your ratio. So my balanced equation says it's 4 iron for every 2 iron 3 oxide. Since iron is on top in my dimensional analysis, I want it on bottom for the next step. I want to convert it to iron 3 oxide, so that goes on top. Alright, we set up our values beside each mole. And those values are the balanced equation coefficients. So there's 4 irons, so I put 4 moles of iron for every 2 moles of iron 3 oxide. So 2 to 4 ratio is really 1/2. So there's half the amount of iron 3 oxide as there is solid iron. So then we grab our calculator and do a little bit of math. So I got 0.3 times 2 divided by 4. I'm going to have 0.15 moles. But 0.15 moles of what? Well, moles of Fe cancel out, leaves me with moles of Fe2O3. And that was the answer our question was looking for. So we circle our answer and move on to the next one. So our next problem says how many moles of water was needed to produce 20 grams of oxygen gas. So let's pick out our information. It says how many moles of water. Well, here's water. I'm looking for moles that was needed to produce 20 grams of oxygen gas. O2 is oxygen gas. So I got 20 grams of this one. Now this time we're going from the product side converting back to the reactant side. That does not change anything. It's still the same process. We still want to do our mole conversion, multiply by the ratio, and convert back to whatever we need if we have to convert back. So let's set up our dimensional analysis. So I got 20 grams of O2. Now I need to convert that to moles of water. So first thing I got to do is convert grams of oxygen to moles of oxygen. So set up your ratio for that. So since grams of oxygen on top, I want grams of oxygen on bottom, and I want to change it to moles of oxygen. So how many grams are in 1 mole of oxygen? Well, elemental oxygen is 16 grams. There's 2 of them, so that's going to be 32 grams. Now, if you want to stop at that point and do that mole conversion, you can. or you can continue to link your dimensional analysis on in one string of an equation, which is what I'm going to do. So I got grams of O2 canceling out now, and I got moles of O2. I want to change moles of O2 to moles of H2O. So since moles of O2 is on top, I want moles of O2 to be on bottom and changing it to moles of H2O on top. Now this is where our balanced equation comes in for stoichiometry. So there's 1 mole of O2, just 1 mole of O2 for every 2 moles of water. So that's a 2-to-1 ratio. Now this moles of O2 cancels out, and it'll leave me with moles of H2O. That's exactly what I'm looking for, so I can stop at that point. So this is my mathematical string for my dimensional analysis. So let's figure it out. So I got 20 times 1 divided by 32 times 2 divided by 1 is 1.25. 1.25, but 1.25 what? Well, the only unit left over is this moles of H2O. So I stick that on the end, circle my answer. I always recommend in the future double checking your work. Alright, next problem. It says how many grams of oxygen gas are needed to fully combust 100 grams of butane? Let's see if we can pick our information out. So how many grams of oxygen gas? So I'm looking for how many grams of this one. How many grams of oxygen gas is needed to fully combust 100 grams of butane? So I got 100 grams of butane. I'm looking for oxygen gas. So we got a mass-to-mass problem. Now notice both of these compounds are on the same side. That doesn't matter. You can still do your stoichiometry just the way we've been doing, and it works just as well. Works the same way, the same process. So don't let that trip you up. So let's set up our dimensional analysis. So I got 100 grams of butane, which is C4H10. Stick that over 1. Now I can't do a gram straight to a gram. I got to convert that to moles. So 1 mole of butane is equal to how many grams? Well, we got to use our periodic table and add up that molar mass. Carbon is 12. I'm going to round to the nearest whole number. Carbon is 12. There's 4 of them. Hydrogen is 1, and there's 10 of them. So butane is 58 grams for its molar mass. So that'll cancel out my grams of butane, leaving me with moles of butane. I can't stop there. Once I got moles of butane, I need to change it to moles of oxygen. So that's where our stoichiometry comes into play. We set up another ratio with our balanced equation. Butane's on top. Now butane goes on bottom. We want to change it to oxygen, so moles of oxygen go on top. Now we use our balanced equation. How many moles of butane will I need for my moles of oxygen? Well, I got 2 moles of butane for every 13 moles of oxygen. 13 goes on top, 2 goes on bottom. That'll leave us with moles of butane canceling out, giving us moles of oxygen. But we're looking for grams of oxygen, so I got to do a mass conversion, a mole to mass conversion. Well, that's pretty simple. Since moles of O2 are on top, moles of O2 go on bottom, I want to change it to grams of O2. In 1 mole of oxygen, how many grams are there? Well, 16 times 2, that's 32. These moles of O2 cancel out, leaves me with grams of O2, and that's exactly what I'm looking for. So there's my string. There's my equation that I need to solve. So let's do that. So I got 100 grams of butane times 1 divided by 58 for its molar mass gives me 1.724. Times it by the ratio, so times it by 13. I divide it by 2. And that gives me 11.21. Now I need to convert it to grams. So I multiply it by 32. And my answer is 358.6. So I got 358.6 grams. There's my unit of O2. So there's our answer. Let's do another one. It says if 30 grams of sodium chloride reacts with an excess amount of magnesium oxide, how many grams of sodium oxide and magnesium chloride will form? So we're looking for two different answers this time. That's no big deal. We'll just have two different strings, two different dimensional analyses. But the first thing I noticed with this problem is it's not balanced. So we need to balance that real quick. Doesn't matter where you start, just pick somewhere to start. We'll start at the left beginning. So I got one sodium, two sodiums. If I stick a 2 right here, it'll balance my sodiums. They're now 2 and 2. My chlorine changes. It's 2 chlorines. Got 2 chlorines. That's okay. One magnesium, one oxygen, one oxygen. Oh, looks like we're balanced. Next thing we need to do is pick out our information. I got 30 grams of sodium chloride. So NaCl is sodium chloride. We reacted with an excess amount of magnesium oxide. That means I'm not going to worry about this guy. I'm not going to deal with it at all. How many grams of sodium oxide? So I'm looking for how many grams of sodium oxide and magnesium chloride will form. So this one's going to have two answers. So let's convert to moles first and go from there. So I got 30 grams sodium chloride. I need to change that to moles. Grams is on top, so we put grams on bottom to cancel it out, and I'll change it to moles of sodium chloride. Well, in 1 mole of sodium chloride, how many grams are there? Sodium is, 23. Chlorine's 35. Should make 58. I believe that's right. So 30 divided by 58 gives me 0.52 moles. Now this particular instance, I am going to stop it right here on this string because I'm going to take this value, this 0.52 value, and I'm going to insert it into two dimensional analyses underneath, just so I have it separated out. So let's do this first one. I got 0.52 moles of NaCl, and I need to change that to grams of Na2O. So first we got to do a mole conversion. Got to use our balanced equation to do stoichiometry. Moles of NaCl are on top, so now I put that on bottom, so it cancels out. Now I want to change it to moles of sodium oxide. So moles of NaC cancel. But what are the values here? Well, there's 2 sodium chlorides for every 1 sodium hydroxide. For every 1 sodium oxide, excuse me. So 2 NaCl's for every 1 Na2O. That changes me to moles of sodium oxide. I need grams. So I got to do one more string, one more proportion, one more setup. Moles of Na2O are on top. I put that on bottom now. Now I'm going to change it to grams of sodium oxide. So 1 mole of sodium oxide has how many grams? Well, sodium is 23. There's 2 of them. Oxygen 16. So that should be 62 grams. So moles of sodium oxide cancel, leaves me with grams. That's exactly what I'm looking for. So now we can begin our math. So 0.52 at the beginning times 1 divided by 2 times 62 divided by 1. We're going to get 16.12 grams of Na2O. So there's our first answer, but we got one more to go. Next, we want to find magnesium chloride by mass. So I'm going to scroll this down a little bit so I got room to work. Change colors. Alright, so we're going to start with 0.52 moles again of NaCl. Stick that over 1. We got to go through the same exact process. We got to do our mole conversion and then our mass conversion. Moles of NaCl is on top, so we stick it on bottom for the next step. Now I'm going to change it to moles of magnesium chloride. So that'll cancel out my moles of sodium chloride. Need some values for those moles. Go back to our balanced equation. Well, for every 2 sodium chlorides, we're going to produce 1 magnesium chloride. So we're going to have 2 sodium chlorides for every 1 magnesium chloride. And again, that comes from the balanced equation. So 2 sodium chlorides for every 1 magnesium chloride. Alright, now we got that, we can continue on with our mole to mass conversion. So now we got moles of magnesium chloride. We need to change it to magnesium chloride. So moles of magnesium chloride goes on bottom. I'm going to change that to grams of magnesium chloride. Well, how many grams is 1 mole of magnesium chloride? Go to your periodic table, look up magnesium and chloride, just add those atomic masses together. When you add those up together, you should get 95, and I am rounding to the nearest whole number. Now we can do a little bit of math. So 0.52 moles of sodium chloride times 1 divided by 2 times 95 divided by 1. And I get 24.7 grams magnesium chloride. There's my second answer. Alright, let's do one more problem. It says how many atoms of water will form from the decomposition of 50 grams of hydrogen peroxide? That's a new one. It says atoms. So how do we solve for atoms? To do that, you got to use Avogadro's number. So 1 mole of any substance is equal to 6.022 times 10 to the 23rd atoms. So once you find your moles, all you got to do is a simple conversion to change moles to atoms by using that value. It's no different than changing moles to grams or grams to moles, really. So let's start this thing off. So how many atoms of water will form from 50 grams of hydrogen peroxide? Alright, there's our information set up. So let's just knock this thing out with a little dimensional analysis. So I got 50 grams H2O2. Need to do a mole conversion. They change mass to moles. So I got to change grams of H2O2 to moles of H2O2. Well, how many grams are in 1 mole of H2O2? Oxygen is 16. There's 2 of them, so that's 32, plus another 2 for the 2 hydrogens. So that's going to be, what, 34 grams? So grams of H2O2 will cancel out, giving me moles of H2O2. Then I need to do my stoichiometry, my balanced equation ratio. Change my moles of H2O2 into moles of H2O. So we need a balanced equation. Problem is, I forgot to balance my equation at the start, so let's do that right quick. Shouldn't be too hard. So I got 2 oxygens on the left, 3 on the right. So if I stick a 2 right here, gives me 2 oxygens plus another 2 oxygens is 4. Also, 2 times 2 is 4 hydrogen. So all I got to do, stick a 2 right there. I got 4 hydrogen, 2 times 2 is 4 oxygen, 2 plus 2 is 4 oxygens. Now we're balanced. Alright, so let's continue on. So for every two hydrogen peroxides, there will be two waters. So two hydrogen peroxide for every two waters. So that'll cancel out my moles of H2O. Then I need to take moles to atoms. I want atoms, remember, I want atoms. So moles of H2O on bottom. So 1 mole of H2O is how many atoms? We said 1 mole is 6.022 times 10 to the 23rd. So 6.022 times 10 to the 23rd. Alright, so let's knock this thing out. So moles of H2O cancel right there. We got 50 grams of hydrogen peroxide. Do a little mole conversion. So 50 times 1 divided by 34, I get 1.47. Times it by the mole ratio times 2 divided by 2. Still got 1.47. Now I do my mole conversion to atoms. So I multiply that by 6.022 times 10 to the 23rd. And that leaves me with 8.86 times 10 to the 23rd atoms of H2O. And there's our last answer. So again, that's basic stoichiometry. It's very important for a lot of lessons you'll find out later in the future. I highly recommend practicing as much as you can so you get a full understanding to where you can't miss a problem no matter what problem it is. I hope this video helped, and as always, good luck on your tests.